Our today's topic for this video session is Introduction to various organic processes, various unit processes, or I can say unit organic processes. Now, science of organic chemistry is about 200 years old. Around the year 1780, chemists began to distinguish between organic compounds obtained from plants and animals and the inorganic compounds which are prepared from the mineral sources. So this particular history of organic chemistry is very old, and we all know that chemistry can be divided into 5 main branches, which is organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, and last one is biochemistry. So from all of these particular branches, one branch which is known as organic chemistry plays a very important role in our day-to-day life and even in various types of industries. Not only in chemical industries, but in petrochemical industries, in certain biofertilizer industries, as well as in pesticidal industries. So everywhere they plays an important role. And to do that particular thing, we have to understand that what is the difference between organic compounds and inorganic compounds. Generally, the structures which are strong in nature are the organic ones, while inorganic compounds are the compounds which are commonly available or commonly affected or commonly obtained from different types of mineral sources, and it will contain certain types of metals also. So this was about in 1780s, where actually the distinguish or the difference between organic compounds and inorganic compounds was done. So for understanding what are different processes, what are different unit processes, we have to understand certain types of structural representations. So structural representations of organic compounds, it's very important to get the structure, to nomenclaturize the particular structure. So structures of organic compounds are represented in several ways, like the Lewis structure, which is also known as the dot structure, like dash structure, condensed structure, and the bond line structural formulas are some of the specific types. So you can represent your chemical compound structure in various ways, and they will give you an idea that how many electrons are free in our compound, which kind of atom attaches with which particular atom, actually what's the valency of your particular atom or that compound contains which type of atom. So this particular representation plays a very important role, and it gives you an idea about the whole compound. The whole organic compound can be identified or can be just represented using this particular system. Okay, so we will take a look on one of the structures, which is known as Lewis dot structure. Okay, it's most widely used and gives us an idea that how many electrons are actually free. So the Lewis structures, however, can be simplified by representing the 2 electron covalent bond by dash. Such a structural formula focuses on the electrons involved in bond formation. Right? How many electrons are actually involved in bond formation, plus how many electron transfer is done, or how many electrons are transferred from one atom to another atom. So we can get to know that which electrons are free currently and which electrons are taking part in our bond, or they are responsible for the combination, for the bonding of that atom, for the formation of that particular compound. Now, let's talk about the classification of organic compounds. So, organic compounds are classified into different types depending upon their structure. Once again, as I told you, the structural representation or their structure plays a very important role, because their behavior, their reactivity also depends upon their structure only. It is the identity of that particular organic compound. So here, organic compounds can be divided into mainly two parts. Number one, acyclic or open chain compounds. Number two, cyclic or closed chain or ring compounds. First one is acyclic or chain compounds, while second one is cyclic, either closed chain, either ring compounds, which shows you resonance. Right? So it's aliphatic and aromatic, a kind of particular compound, a type of particular compound. Now, the cyclic or closed chain or ring compounds are further divided into two different types. The first one is homocyclic or carboxylic or carbocyclic compounds. They are known as homocyclic or carbocyclic compounds. And another type is heterocyclic compounds. Okay? The first one is homocyclic or carbocyclic compounds, while another one is heterocyclic compounds. Now, that homocyclic or basically carbocyclic compounds are further divided into two main parts. Number one, alicyclic compounds. Number two, aromatic compounds. So basically homocyclic are aromatic compounds, so you can go through that particular one. Okay? And that aromatic compounds are further divided into two parts, benzenoid or non-benzenoid. Right? So they further can be divided into these two parts. Number one, benzenoid. Number two, non-benzenoids. So this is basically how we can classify our organic compounds. So it's aliphatic and aromatic. And aromatic again can be divided into further types. Right? Let's talk about acyclic or open chain compounds. So these compounds are also called as aliphatic compounds, as I told you. The compounds, and basically they consist of straight or branch chain compounds. We will take here the examples. So as you can see in the image, ethane is basically, that ethane is a acyclic compound, a chain compound. Okay, it contains a chain structure. Isobutane, as you can see in the image, 3 straight chain of carbon is there, and 1 carbon will be attached to the central carbon atom. So in this manner we get that particular isobutane. Now another example is acetaldehyde. As you can see it again, it contains 2 carbon, 1 oxygen and 1 hydrogen, basically 4 hydrogens. So contain a chain structure, a straight one. So it's known as acetaldehyde. It's again acyclic structure. Then we have acetic acid. So Ca3C double bond OOH, that basically is an acetic acid. And you get to know that here again it contains a straight chain structure, right? Second one is alicyclic or closed chain or ring compounds. So alicyclic, that are also known as aliphatic cyclic compounds, contain carbon atoms joined in the form of ring, right? So it's homocyclic. And sometimes atoms other than carbon are also present in the ring, which are known as heterocyclic compounds. Some examples of this kind of compounds are cyclopropane, cyclohexane, then we have cyclohexene, tetrahydrofuran, etc. Right? So what's been there? It's cyclopropane, cyclohexane, tetrafuran, or you can say cyclobutane, cyclohexane, cycloheptane. So this all are basically the cyclic, they contain a cyclic structure. Okay. Now let's talk about aromatic compounds. So aromatic compounds are special types of compounds, and this include benzene and other related ring compounds like benzenoid, like alicyclic compounds which are aromatic compounds. We also have heteroatom in the ring. And such compounds are called heterocyclic aromatic compounds. Some of the examples of various types of aromatic compounds are benzene. So it is again divided into two parts, benzenoid and non-benzenoid. So benzene, aniline, naphthalene are the three ones which are considered as our benzenoids, while non-benzenoid is tropolone, right? So as you can see here, it's non-benzenoid. So this is basically all about what are the different types of organic compounds and how they play their role in different organic processes, right? So we need to make sure that depending upon their structure, they will utilize in different particular reaction in different ways. So what we will do here is basically we understand the structure, we understand the valency, we understand how many electrons are there, and depending upon that we will carry out our further reactions. So they will again plays an important role in every kind of organic processes, specifically in unit processes. Okay, so this need to be made sure that how it will give rise to the particular organic product. So this is all for this session. Next we will see in our next session. Thank you so much everyone.